Okay, thanks for coming along. We've still got couple of people filtering in, but we'll get started anyway. My name's Mitch Denny. I'm a program manager on the VSTS team, and I'm Australian, but I live in Redmond. So I came over for the conference to have a chat about VSTS, and in this case, having a chat about how to build continuous delivery pipelines for ASP.NET Core applications. And so I'm going to build that continuous delivery pipeline on top of VSTS, and it's going to push that application into Azure. But before we get started, we need to do a bit of a primer so we can understand some of the technologies at play here. Because generally speaking, most people are at different levels in terms of understanding the various bits and pieces involved, and there's quite a few moving parts. So let's get on with that quick primer. There's essentially four things that we need to understand for this session. We need to understand what .NET Core is. We need to understand the relationship between .NET Core and ASP.NET Core. And of course, we need to understand Docker as a way of delivering applications into production environments, and then how you can use VSTS to do that. So .NET Core. Now, before I get started, who's already working with ASP.NET Core today? A couple, great. So .NET Core is the foundation of ASP.NET Core, and the idea is that it provides a modern development framework. So if you think about .NET, it's been around for a while, and when it was first released, it included a number of frameworks for building web and desktop and in some cases mobile applications. And as time's gone on, the needs of those applications have changed, and there's elements of the framework which were once important are now less important today. The fact that we're releasing .NET Core doesn't necessarily mean that the old framework is going away. We'll still continue to have two frameworks, but for people building these modern applications, they can start to take advantage of this lighter weight framework, which is more optimized for those apps. One of the things that's changed in the way that we use .NET dramatically over the last couple of years is the way that we distribute our dependencies. So when .NET was first released, one of the things we used to do was copy around DLLs and reference those DLLs directly between solution files if we were working across solution files. Obviously within VS it managed all that for us. And of course NuGet came along and we started managing all of our dependencies as NuGet packages. But the runtime and the tooling itself didn't really know anything about that. And so things like NuGet were kind of sort of hacked into .NET, into the .NET toolchain. So what we've done with .NET Core is made this concept of packaging a central tenet. I'll mention a little once or twice around the way that you can produce packages with the build tools here, but the main gist of this session is building a CI and CD pipeline. And of course, the big thing that we've achieved with .NET Core is cross-platform support. So when it comes to ASP.NET applications built on top of ASP.NET Core, we've actually got the ability to deploy those apps on OS X machines or Linux machines or Windows machines. Okay. Now, ASP.NET Core itself has a much more flexible hosting model for your web applications, whereas previously you would have to host your application in IIS, and then over the years we introduced things like Kestrel and various hosting models. .NET Core was built from the ground up to be much more flexible in the way that your web application is hosted. And that was necessary to be able to achieve cross-platform support. In fact, this has paid some real dividends in terms of performance, where you look at plain text execution tests, you can achieve something like 1.8 million requests per second with .NET Core. So it's a pretty performant engine. And at the same time, the goal was to simplify the architecture a bit in doing that. So .NET Core is finding its way into a bunch of different areas. Obviously, ASP.NET is one of them. But you'll also find .NET Core in UWP applications as well. And there's slightly different versions of .NET Core. There's lots of sort of point-in-time synchronization issues between those tool chains, but generally we're converging on a more consistent framework across all those applications. But the road's been, a little bit rocky, but I think we're in a pretty good place now. Now, before I go on and I start talking about Docker, I wanted to sort of take a moment out and talk about some evolution that's happened in the tool chain for both .NET Core and ASP.NET Core. So if you picked up these tools 6 months ago, 12 months ago, when they're in the earlier stages of development, you would have been familiar with a file called project.json. Now, the project.json file has actually gone away, but what was contained within it is staying. I think there was a bit of a hard lesson learned. If you look at .NET Core, one of the goals was to make it really easy to get started. And so you could basically just create a quick JSON file, punch in a few keywords, and away you go. But what we learned over the last probably 12 months now is that this created some pain in some of the other tooling areas of things like Visual Studio. So a lot of the people who build ASP.NET applications are obviously using Visual Studio, and we removed the MS build file that was used to produce those web applications, and we replaced it with project.json. But in order to work successfully within the IDE, we actually had to put it back, and there was kind of this interesting relationship between your CS proj file and your project.json file. And so in the end, the decision was taken to say, hey, let's go back to just using an MS build file, but at the same time, let's drastically simplify the contents of that file. And so when you look at a .NET Core application, whether it's a console app or a class library or an MVC application, that file is dramatically simpler. And so there's a lot more assumptions built into the build process to accommodate for that. Now, before I go on, are there any questions about that sort of base understanding of .NET Core? Sure. So the question was, can I give a definition of what .NET Core actually is? .NET Core is a runtime, and there is also a framework in there as well. So the distinction between, say, what we call the .NET framework, which is what you use currently, and .NET Core is that they're roughly analogous. One of the differences between the two is that .NET Core has been much more componentized. So today with .NET Framework, when you install it, you kind of get the whole framework. With .NET Core, when you package up your application, you only take in the dependencies that you need. We pre-install .NET Core onto the local machine when you install your dev tools, but that's more about efficiency. But the final application that you deploy is more efficient, is potentially smaller. In addition, there's been a lot of evolution in the tools like the Roslyn compiler and that kind of stuff, but that stuff actually works across both old and new frameworks. And as I said, the .NET framework's not going away, it's just that modern applications have a different set of requirements. And so the .NET framework itself is very mature and stable, and .NET Core is targeting a new kind of application. But they're both runtimes. I haven't heard of any plans for that. To be honest, I'd be really surprised because if you look at the team I work on, for example, we depend on the .NET framework. And so it doesn't make sense for us to replace, say, VSTS with .NET Core, because we actually use some of the things in .NET framework which don't exist in .NET Core. Now, conceivably, at some point in the future, .NET Core could have everything that the .NET framework has, but I mean, why change? So what might happen, what I think will probably happen with a lot of organisations is that as they start to move forward, they tend to componentise their applications a bit more, and they'll make a decision that, hey, this component of my application can actually be a .NET Core application. And so you'll get a bit of a mix. And that's kind of the trend for the future anyway. We're seeing a lot of that when people adopt microservices architectures. They don't necessarily have to make the same technology decision for each component in that system. Okay. So let's have a bit of a chat about Docker. So Docker is it's interesting. How do you describe Docker? Docker is a set of tools that wraps around some native operating system capabilities around containerization. So it begs the question, what do I mean about containerization? The idea, and I would imagine most people here are familiar with virtual machines. Right? So what a virtual machine does is when you spin it up, it basically creates a virtual CPU, it has a virtual disk, it has virtual memory, and it emulates the entire operating system. Containers take a different approach. They look at virtual machines and say, hey, that's incredibly inefficient. With containers, instead of having all of that overhead, we're just going to make it so that when we start this particular process, we're going to shield the rest of the operating system for everything running underneath that process. So it kind of creates this opaque view of the underlying operating system. And so things that are running in a container are actually running on the host, but they're shielded from making certain calls on the system. And any changes they make to the file system are isolated into that container. Now, Docker actually relies on some kernel capabilities in Linux today. And Microsoft realised that, hey, containers is a smart thing to do. So Microsoft actually went and invested in building container support in Windows. The approaches for implementing containers on Windows and the approaches for implementing containers on Linux are different, right? So they're different architectures. Docker spans both of those tool chains, both of those platforms. So it provides a common layer on top. And so Docker is not a Microsoft technology, but Docker supports the underlying platform and capabilities around containerization that are now in Windows Server. So during my session today, I'm going to focus mostly on deploying an ASP.NET Core application into a Linux environment, but containers work on Windows as well, and you can use the Docker commands to do that as well. And so when we talk about Docker files, which I will in a second, you can use the same approach for configuring containers on Windows. So on a Linux machine, if I've got a Linux desktop here, and I brought that up and I started using the Docker commands, when I create a container, that container is running on that Linux box. The Docker tools that you can install on Windows and OS X actually set up a virtual machine. So they create a virtual Linux machine and whatever the appropriate virtualization technology is on each of those platforms. So when you install it for Windows, it actually spins up a Linux VM inside Hyper-V. But if I install it in OS X, I think it spins it up in, what's the name of the virtualization technology they're using there? So I think it's the Sun virtual machine environment. But, sorry, what was that? VirtualBox, yep. Sun, but that's from Sun, right? So, or at least it was. Okay, so that's the way that they get around that Linux limitation, because OS X itself doesn't have containerization support. Windows does. So you can use the Docker tools natively on Windows, but if you want to use the Linux containers, it spins up a virtual machine and runs the containers within the Linux virtual machine. So one of the central things that you'll be doing when you're working with containers is creating Docker files. So this is a Docker file, and this is a really simple Docker file. I'll actually go and recreate this in a few moments so we can get familiar with using the tools, but I wanted to sort of explain what goes on here. So at the top of this file, so the file is literally called Docker file. You'll have a text file, no extension, just Docker file in your file system. And the first line is telling you, I want to create an image from this baseline. So from the Ubuntu latest image, I want to go and run these commands. And so as it progresses through these commands, it creates these images. So when I execute from, it'll go and pull down that Docker image from whatever my container registry is, and there's a public one that it just works with by default. And then it runs the apt-get update command and creates another image. And then it installs, in this case, the GCC tools. Then it maps the current working directory of the Docker executable into the container. And so that's how you can pass data into the container. And then within the container, I set the current working directory. And then I run the compiler, and then I run the compiled output. This is just an example of the kind of thing you could do. In fact, a lot of people do this kind of stuff to isolate their build process into a container. And we're going to go through and do some of this in a second. The Docker ecosystem is made up of multiple components. So Docker is a company, and they produced Docker, and then they went on and produced a bunch of other tools. So there's a tool called Docker Compose, which is a way of orchestrating the deployment of multiple Docker containers. And that Docker Compose tool can talk to a Docker Swarm, and Docker can talk to a Docker Swarm. And a Docker Swarm is, imagine it's an endpoint for deploying multiple containers as if that cluster of machines running those containers was a single machine. So it's a simple way of scaling out your Docker environment. And then, of course, there's this place where you store your Docker images, and that's, Docker provides a centralized open source hub for Docker files. There are other components in the ecosystem. So one of the things that was discovered fairly early on was that if you're going to have all these containers, which you can spin up very cheaply, you need some kind of way of managing them. Not only the provisioning and deployment of those containers, but also the relationships amongst them. And so there are, I guess what I would call is container management services. So Docker Swarm is one of them, but there are other ones. So there's one called DCOS, and there's one called Kubernetes. And what we've done in the Azure platform is build something called the Azure Container Service, which supports all of those. So when you spin up an Azure Container Service cluster, you can say, hey, I want to provision this cluster using Docker Swarm or Kubernetes or DCOS. And then that controls the way you deploy and manage those VMs, those containers. The other component of the Azure container story is a registry. So I mentioned that Docker has Docker Hub. That's by and large used for publishing of Docker files and sharing them so people can reuse other people's images. But one of the challenges you've got to watch out for there is if you're going to start using Docker for real and you take a dependency on a public image or a public Docker file, that someone can't slip something into your environment. So you've got to be careful and selective about what dependencies you take in terms of underlying images. And so most organizations which are doing containers for real will have some kind of self-hosted registry of all of their Docker images. And that's for security reasons. And not only that, they just don't necessarily want to share all of their images with the rest of the world. Although Docker Swarm, you can have some Docker Hub, you can have some private views as well. So they're the two big components. You can also just spin up a Docker machine in Azure and manage that yourself. We've got templates. So, there's sort of going from the cobble it together yourself to a template which provision it for you to a full container service, which like Azure Container Service. Now, in this session, I'm going to be focusing on building a VSTS a continuous integration and continuous deployment pipeline, and so I'm going to use VSTS for that. And so we've got some tooling built into VSTS to make it easier to work with Docker, and we'll demo that today. So let's do some warm-up exercises. All right, let's start understanding the way these individual components work. And I realise some of you are already working with .NET Core, so bear with me. Okay. Okay, so let's work with .NET Core initially on the command line, and then we'll look at it inside Visual Studio. .NET Core provides a command line called .NET. And I'm not expecting you to read all that, but basically it's a command line tool to make it possible for you to easily provision a .NET Core application. And so I can create a directory. So mkdir hello core, and I'll CC into that, and then what I'm going to do is I'm going to go .NET new, and I'm going to create a class library. Okay, so I go .NET new class library, and it just uses a template for doing that. Fantastic. Now what it's doing is it's downloading the .NET Core runtime, or in this case I've already got it downloaded, so it's decompressing it and installing the components that I need for a class library. And I actually didn't think it would do that. I thought it was kind of already done. So whilst we're waiting for that, are there any questions on Docker so far? Sure. So the question was, what is the Azure Container Service? So the Azure Container Service is an attempt to provide a relatively easy to manage container host. So if you're going to run Docker containers, they've got to run somewhere. And so with the Azure Container Service, you can spin up a cluster of machines on which to run containers, and then you choose between Kubernetes or DCOS or Docker Swarm to manage all of those virtual machines. And then you can deploy a container to ACS and it distributes it out to that environment. So it's really about providing a management layer to a set of VMs running containers. Not sure why this is taking so long. Interesting. There we go. Okay. Strange. So what I'm going to do here is I'm just going to bring up VS Code, and we're going to look at what this thing created. So you can see here I've got two files. One is class 1, and one is hellocore.csproj. So if I'd wound back the clock 3 months or 6 months and run this command, it would have actually generated a class file like this and a project.json file. So this has replaced the project.json file. And in fact, there is a command, if you've already gone down the path and you've got projects with project.json, there is a .NET migrate, which I would say does a reasonable job of migrating project.json files over to csproj files, provided you haven't gone too insane with the customizations of your project.json file. So sometimes there's some manual translation that you need to do. And that was just one of the side effects of trying to move back to MS Build under the covers. So if you've ever opened up a csproj file before, one of the things you would know is that it kind of scrolls off into the distance and it's got all these references out to different targets files, and it's kind of fairly incomprehensible. Well, one of the things that we've done with .NET Core is simplify that dramatically. So we don't have the XML namespace anymore. That's not necessary. We discarded the need for that. But we've still got the project element in this XML file, and we've got two really important configuration values. So the first one up the top is SDK equals Microsoft.NET.SDK. That is a shorthand way of bringing in a whole bunch of targets which are required to build a .NET Core application. And the other one is the framework that you want to target, for example. And so I can go .NET restore, and that restores the packages from the public feeds, and I can go .NET build, and now it will actually go and produce a DLL file. I might just reduce the font size. I probably got a little bit carried away with that. It's probably a bit better. Everyone can read that? Okay, cool. I was helping you by blowing it up to about 2 stories tall. Okay, so basically I've done a .NET restore, so I've restored the NuGet packages which are used under the covers within this particular project, and then I've done a .NET build, and that's produced the DLL. Now, .NET Core, I said one of the things was around transferring dependencies around, so I can actually do a .NET publish, .NET pack, and it will actually produce the new package file. So this is your NuGet file. And so you can actually, if you did this as part of a build process, you could then publish this to the VSTS package feed or one of the public package feeds for NuGet. And so this concept of packaging is kind of built into the product, and you can just go into the MS build file if you want to control the version and add a version element. So if I want to produce a 2.0, it's relatively easy to do that. There we go, and that's how we produce the 2.0 version. So the whole world of class libraries and NuGet has kind of come together, and it's hopefully going to be more consistent moving forward. It's one of those things that you need to do with modern applications. Okay. So the next thing I want to do is show the difference between, say, a .NET Core class library, or this is very similar to a console application, and an ASP.NET application. So this time I'm going to say create a directory, hello ASP core, change into that directory, and I'm going to go .NET new, and there's a whole bunch of templates we can use. So there's Angular templates, there's React templates, and they'll generate a web application with all of the underlying ASP.NET stuff you need, plus those other frameworks included. But I'm just going to create an MVC app. Good thing that was closed. And If I go in here, you can see that there's a whole bunch of additional files that are created in this particular instance. So if I open that up in VS Code, now I'm using VS Code here just because it's convenient in this particular scenario, and we're going to move to Visual Studio in a second. But in this case, there is a lot more content. And this is where you start to get a feel for the differences between the classic ASP.NET .NET Framework style application and a .NET Core application. First of all, a web application in ASP.NET Core is a console application. And so when an ASP.NET Core application starts, it's just like a console application starting. It's not anything special. Inside the main line, I'm sure that's helping me if I press yes to that. Inside the main line, I think it's actually installing some of the components I need. Inside the main line, what we do is we construct this web host builder, and we tell it about where our files are located, and we set up the integration between IIS if we happen to be using it. But in this case, we're just going to use Kestrel, which is a built-in web server. And then finally, we tell it where is the configuration settings for our application defined. We build the web application or the web host and then run it. All right, so it's you could actually spin off other processes here as well if you wanted to have, a web application plus some background processing. So now if I go .NET Restore, it's going to pull down all of the ASP.NET packages, which were already here, and then I'm going to go .NET Build, and it's going to compile this application, and then I'm going to go .NET Run, and what's going to happen is it's going to spin off that console app. It's inside a DLL, but there's like a framework that sits around it. And now it's listening on port 5000. So if I open up a browser, and hit enter, oops, did I, 5000, what did I do wrong? Oops, that's muscle memory. Okay, so now that console application, which is hosting the Kestrel web server, has now served up an ASP.NET Core application. Okay, so that's the basics. Okay, so let's jump in and look at how this works within Visual Studio. It's not that dissimilar. So if I go in and I create a new ASP.NET Core application, and I'll just go hello VS ASP Core and click OK. It's going to bring up this intermediate chooser, and I can choose between what version of the runtime I want to use. And we've got an option here to enable Docker support, and I'll come back to that a little bit later on. I'll leave it checked on for now. It basically produces exactly the same thing that I'd produce via the command line, but it's all done within the IDE, and we've got a solution file in addition. So if you want to manage multiple projects, VS is pretty good at doing that, but the .NET Core command line has some utilities for managing a solution file as well. But what this template's actually done is create a whole bunch of Docker-related files. So the wizard's kind of got Docker in mind. So that's kind of should show you how important Docker support is. So we'll sort of jump over to looking at Docker in a second. But basically, in this case, if I run the application, it's actually going to use this Docker file, which was created during the setup of the project, to run this ASP.NET application on a Linux box. So previously, what I just ran on this machine was on a Windows host, and now when I run this, it's going to spin it up inside a Linux VM. So it's doing the .NET Core build, and then it's creating the container, and then it's going to deploy the container onto a Linux VM, which is running on Hyper-V here on my local machine. And when you install VS 2017, we've actually got an option to install all of the Docker tools to make this possible. So we've got these different options. So if you want to work with Docker, you can click the Docker support to install these components. And what's happening here is it's actually pulling down the ASP.NET Core image. So we actually provide a base Docker image which has all of the underlying .NET components necessary to run a .NET Core application on top of Linux. And in a few moments, should spin up. That first start is usually a little bit longer because you've got to pull down the images for the first time. Okay, and there we go. And debugging works here, so we've got the ability to debug these .NET Core applications inside the container, and this is exactly the same as exactly the same as what we saw previously in terms of the application. It's just running on a Linux box. So that's the Docker support inside Visual Studio. Now let's have a little bit of a closer look at the Docker files and just understand how that process works. So I'm going to kill this application now, and I'm going to create a directory called Hello Docker. Because we're really still going through the process of learning those essential skills we need to build and deploy one of these pipelines. Now in this case, I'm going to just forget about .NET Core for a few moments. I'm just going to focus purely on Docker. So here, I've got my source tree here, and I'm going to create a new file, which is a Docker file. So the first thing I want to do is I want to create a Docker file which is based on an Ubuntu image. So I'm going to go from Ubuntu, and I'm just going to grab the latest one. There are different Docker images you can take, and that can potentially increase stability. And you'll notice here that I'm using the Docker extension for Visual Studio Code, and it actually helps me find the Docker images that I want, which is kind of handy, because I do a pretty good job of forgetting what all the Docker image names are, and I usually have to go searching for them. So the next thing that I'm going to do is I'm going to update the dependencies on this particular machine, so to make sure I've got the latest binaries and so on. So I'm going to run the apt-get command and run an update, and then I'm going to run the apt-get, and I'm going to install the GCC compiler, because I'm just going to do this to demo compiling a little C file. And then what I'm going to do is I'm going to add in the current directory as the source folder, and then I'm going to set my work directory to the source file, and notice I'm getting IntelliSense. And then finally I'm going to run another command, which is GCC to compile a C file, and that's the end of my Docker file in this particular case. Now of course I need the C file now, so I'll go hello.c, and this is just a simple program. There we go. Hit save, and that all looks fine to me. So now I'll drop back to the command line, and now I'm going to use the Docker command line tools to build that image. So when I do that, I use the docker build command. Oops, docker build dot. So it's basically looking in the current directory for something called Docker file, and so it already had from memory it had the Ubuntu image on my local machine, and now it's running the apt-get command to pull down all the updated packages for my particular image. That'll run for a few moments. And I don't know what that error is about. We'll ignore it for the time being. Hopefully it doesn't break anything. So whilst we're waiting for that to go, anyone got any questions while we're waiting for that to just run through?
Just be clear, if you're not doing multi-platform development, is container still relevant?
It is. Look, the Windows container support is relatively new, but where this is going is that even if you ran, okay, just making sure that was successful. Even if you run your applications inside a Windows container, that can provide some benefits in the portability of the container between machines, because it kind of creates an isolated environment where you kind of know that all those dependencies are controlled and contained. So it'll make it easier to move it from one machine to another. So in time, you'll see Windows support where you might have a container service which includes Windows and Linux machines, and you just choose the platform you want to work with. And so your build process will just generate a container, and it's just easy to move it from environment to environment. Think of a container as just a drag and drop way of deploying your application to machines.
Does it solve the issue of having multiple applications, say on a production server, and you've got to do something on the server, and you've got to pick all your applications? So with a container, can you just bring down the one container and then the other ones run?
Yeah, that's right. So it's an isolation boundary. It's not as isolated as virtual machines, and so the Windows support has an additional feature where not only can you run containers, but with the flick of a switch, you can run that container in a virtual machine to get increased isolation. But for most internal applications, just using containers without virtual machines will be sufficient. But if you're running a container from a third party and you might be worried about security, for example, you can spin that container up inside a virtual machine in addition. There's some additional overheads there, but it's peace of mind in terms of security. But containers are generally sufficient for providing isolation between the stuff running in the container and the host. Okay, so that completed. That warning was just a cease index warning, but it's produced the image that I wanted. So you'll notice that there is this successfully built and some number, and throughout this log file you'll see text saying removing intermediate containers. So it's gone and built all those containers, and now it's kind of collapsed them all into one, so it's a nice easy single image to deploy. And so what I can do is I can go docker run, paste in the image, and I'm now running inside the Linux machine, okay? And if I go ls, you can see that I've got my Docker file and I've got my C file, and I've also got my hello executable. And if I run that, I get my hello world out the back of it. So this is your basic mechanics of using a Docker file. And there's different commands you can run in there for doing things like passing commands in and exposing ports. And we're going to go on and move into that. I've got both of these lights on up here. One's flashing. Hey. Hey, I've got one light on solid and one flashing. Sorry guys, we're going to have to reboot the AV gear, so I'll tap dance. Go for it. Yeah, so some of those attributes that we used to use, we don't need to use anymore. I always felt like I was setting the version number in about 3 different places anyway. So this gets us into a more consistent way of setting the version across both the NuGet package, the underlying assembly, and when you set that version flag, and there's a bunch of other elements you can put in there, that also updates the metadata in the DLL, so it flows all the way through.
So there's a place to do it, right?
Yep. Go for it. Yeah, so when you create the container, you can actually label it. So I didn't label it, but when you do the docker build command, you can actually pass in some additional arguments to say this is the Mitch food container, for example. And then once you do that, that image exists on your local machine, and then you can publish that to a registry.
And then you can now use that data.
Exactly, yeah. So if you've got a baseline.
Does Microsoft have any plan to running these commands on the VSTS? Because obviously, as a team member, so we're all gonna Docker container and that kind of stuff, and then we can publish or deploy that Docker container or to somewhere else.
Yep. I'm going to show you that, hopefully. So that's exactly what this presentation is about, is going through that scenario. So we're good? We're good, fantastic. Okay, hopefully I don't mash the buttons again. Okay, so we've done file new project, we looked at the Docker file. Let's talk about Azure and Docker.
Excuse me, I'll just change it from this end. When you want to change, I'll change it from this end.
Sounds good, all right. So let's change it then. We'll switch it over. What I'm going to do is log into the Azure portal now, and we're going to look at the elements in Azure, just so I can describe what some of the moving parts are. Okay, so in the Azure portal here, I've actually already deployed an Azure Container Registry and an Azure Container Service. And so that's what all these components are. Now, this might look pretty complex. About 5% of this is the Azure Container Registry. The other 95% of it is what's required to run a proper secure container service. And so you'll see here that there is a registry that provides the API required by Docker in the cloud to publish and share images. It's really just the front end. It stores all of its data inside a storage account. So when you upload an image, it's basically a blob, and it throws it in this storage account. Everything else in this list is the container service. And the container service is kind of like it's a top-level element, but there's a whole bunch of underlying Azure components that make it up. It runs on two sets of virtual machines. You got some master VMs which run the container management software, and then you've got a set of VMs, or at least two sets of VMs, which run the containers themselves. So I just wanted to point that out. So the way that you create these things, and we won't go all the way through to create this because it can take about 20 minutes for it to fully finish provisioning, but I just wanted to help you find it in the future when you do it yourself. You just go and create an Azure Container Service, and it goes and requests a whole bunch of configuration detail, and there's documentation online about how to configure these containers. For the tool I'm going to show you in Visual Studio, it's very important that when you provision this container, that you use the DCOS container management software, because the tool I use requires that in order to streamline the configuration of everything inside VSTS. Yesterday I was setting this up and I forgot to set that, and so I had to go through and recreate it all from scratch. So the container service requires an SSH key, so you can use PuTTyGen to do that. And it deploys into a resource group where all those VMs and everything is configured. Okay. So I might switch that back now if that's okay. Thank you. Okay, so what we're going to do now is go and build a CI and CD pipeline. Now, if you're going to go and do this from scratch, there's a whole bunch of stuff you'd have to do. You'd probably end up with a fairly, if I asked each of you to go and do it, you'd probably end up with as many different solutions in the room as there are people. Okay, there's quite a few steps and quite a few different ways of doing it, and that's a bit of a challenge. So what we've done is we've created some tooling to simplify that. But basically what we're trying to achieve is we want to set it up so that when I check in some source code into a version control repository, it triggers the VSTS build, and then it pushes that Docker image I've created up into the cloud. Okay, so this is just some blob storage, and then which would be front-ended by the Azure Container Registry. And then I want to use VSTS release management to push it out into multiple environments. And finally, when I deploy that, I want my container service to pull the image down from that container registry. And so that involves a bunch of steps. First of all, you've got to set up your registry and container in Azure, which I've said takes about 20 minutes. Then you need to set up your source code repository. You've got to set up a bunch of service endpoints that tells VSTS how to talk to the Docker endpoints. Configure a build definition that uses those service endpoints to drive the code. And you've got to set up the release definition with multiple environments. So it's kind of a laborious process. You don't have to do it. All right, there's a fast way. In fact, I was going to do this for the demo. I was going to show you a manual one, and I thought, I'm never going to get this done in time on stage. So I thought I'd cut to the chase, show you the cool stuff, and then we'll walk back through what it actually did as a better way of doing it. And in fact, if you want to learn how this stuff works, that's probably the way I'd recommend doing it. So we're going to use the continuous delivery extension for Visual Studio. This extension requires VS 2017. And if you haven't pulled down 2017, I would definitely recommend it. We've got some great support in there for Docker. It's kind of required. There's a short URL to find it. And obviously, Visual Studio is 2017 is coming out soon. So it's pretty rock solid. In fact, I've been running it for, let's call it 6 months every day, and it's gotten better every day. So the continuous delivery extension has a couple of prerequisites, some things it doesn't do for you. One of those is you've got to have a container registry and a container service configured. I've already done that, but it does everything else in terms of stitching things together. And then you've obviously got to have your application that you want to deploy in source code. So let's see how it works. So could I switch back to the... Fantastic, thank you. Okay, so I'm just going to do a file new, well actually what I'm going to do is I'm going to start inside VSTS. So I've got a demo account that I'm using here. And there it is there. And I'm going to create a Git repo. There we go. And I'll initialize it. Excellent. Now, normally, you would go through the process of setting up your CI builds yourself, but we're going to use a tool to do it for us, so we'll just ignore this for a moment. We'll just clone this repository down locally. Don't need this Docker container anymore. Having exited that Docker container, it stops. So that's just something to keep in mind. So I'm going to go git clone, and I'm going to clone down that repository, and I'm going to create a project within there. There we go. So back into Visual Studio, File, and close the solution, don't need that. Maybe stop the debugger, that's probably a good thing to do. File, new project. So I'm going to create an ASP.NET application, and I'm going to drop it in the repo that I just pulled down. There we go. And I'm going to call this Docker CI/CD2 hello ACS. Okay, I'm being a little bit specific about what I'm doing here because I'm just sort of sidestepping a bug that I found this morning. Basically, this tool doesn't like it when you've got the solution file sitting in the root of the repository. I haven't been able to figure out what's causing it, so I'm just skirting around that. If you're wondering why I'm being a little bit pedantic about how I name these things, I'm assuming that bug will be fixed. Okay, so this is going to be exactly the same as the project we saw before, but it's going to be sitting within the repository that I want to share. And what I'm going to do now is commit that code and push it up to the server. So stage these changes. Please work. Commit. Okay, So that's going to synchronize up to the server now. And once that's up, we're going to go on to this process of setting up our CI and CD pipeline. And unlike a lot of the CI/CD pipelines you set up with VSTS, using this tool you actually start within Visual Studio. So let's just jump across and make sure that's made it up to the server. We'll just refresh this page. Excellent. So we've got our source code there. So the way this works is I go in and I select the ASP.NET project that I've just created, and I select configure continuous delivery. And because Visual Studio is connected to Azure, it's now going to scan my Azure subscriptions for the various container registries and container services that I've got deployed. Okay, it's looked like it's picked up everything correctly. So I'm going to click OK, and in my experience, 30 seconds to a minute, this will be done. So what is it doing here? Okay, so it knows that this Git repository is tied to a particular VSTS account, and what it's doing is it's going and creating a build definition which points at that Git repository, and that build definition has all of the elements in it already to produce the underlying image. That's finished already. And then it's going and creating a release definition with a dev, test, and prod environment, all pointing at the ACS server that we deployed previously. So now, if I jump into VSTS, I go to the build and release section, you can see that I've got a CI/CD build and it's already started running it. Oops, I probably should have selected the actual build that's running. And this has done a couple of cool things. First of all, it's deployed a container into the container service that we pointed at. That container is the build agent which is building this build. So it's a real inception kind of thing. It's deployed a container to build a container. And you with me so far? And then once it's running, it goes and creates another container which then uploads to the registry, the container registry that we configured previously. Now that this build is complete, if I go to the release hub, I can see that it's actually already started deploying this particular Docker container out to the dev environment inside Azure. So if I jump into that and bring up the logs, you can see that it's downloaded the container. Now, the things that it downloaded wasn't the image. The image, after the result of the build process, is already up in the Azure container registry. All it's doing in these particular stages is deploying to the container service, and the container service pulls down from the registry. And so the log file for that step is here, and it goes through and you can sort of see it's uploading everything. And it doesn't take very long. In fact, if I want to go and trigger this part of the deployment, I can go into the summary and I can say, hey, just go and deploy the test environment too while you're at it. And you know what, I'd like to have a production environment as well. And so within a few moments, I've now got 3 environments with that application running in Azure Container Service. None of them are accessible to the cloud, to the public internet. So it deploys secure by default. So let's have a look at how we navigate that. If I go into Azure Container Service here, and I'll go into my resources, there's a whole bunch of resources in this screen, and I just want to sort of pick apart what some of them are. I've got enough time, okay. So there are 2 public endpoints that you get when you deploy a container service. One is a kind of a management endpoint, and one is an endpoint which is actually used by the containers if you want to be able to get public access into the code that's running in the containers. So there's the public IP address, and that's for the agent. And then there's a load balancer which uses that IP address, and this load balancer controls where incoming traffic on particular ports is routed to. And then there's a public, which I can't say, there's a master IP address and a load balancer, and this is the IP address that you use to, if you want to access particular management interfaces. That's one way of doing it. What we've got set up here is the ability to just create a tunnel directly to that machine. So I'm just going to spin that up now. So I'm going to load that. So this is the ID. Interesting. Okay, let me try that again. I obviously didn't save everything. Okay, so I need the private key. I moved the private key. Bear with me. Okay. You know, I tried to tidy up my desktop. That'll teach me. Here we go. And bring up PuTTY again. Okay, load these settings. That should work this time. Cool. Okay, so it just needed my SSH key in the right place for this to kick off. And what this has actually also done is set up a tunnel. And so when I hit localhost on port 80, I think, I'm now entering the DCOS management console. And you can see here in this particular environment that I've got a bunch of jobs running, a bunch of services running. So if I look in dev, you can see that I've got 2 container services running. This is the second one that I set up. And if I jump in and look at that, you can see I've got the Hello ACS application. And if I drill in on that, we can see that it's there, it's running, it's fine, but it's not actually exposed to the internet. So there's a couple of things I've got to do here. It's a little bit laborious, so what I'm going to do is I'm just going to point it out and then I'll show you one that I've already got set up because it'll take a couple of minutes to update all of the network config. But basically, you have to go into localhost Marathon, and we need to tell Marathon how we want, or we need to change the configuration of this particular container to expose itself on a particular port. And there's a couple of things we have to do here. So I go into edit, and I'm going to tell this thing to move over to a set of VMs which are potentially publicly exposed to the internet. I click change and deploy, and what will happen is that Docker container will now move to another set of VMs. So it's moving into a VM which is on a virtual network, which can get access from the internet via the load balancer. The next thing we need to do is we need to specify the port mappings. And if I jump in here, I can say, hey, I want to map port 80 on the container to some other port. But this UI here doesn't actually allow you to specify what that port is. It will randomly assign one. We're going to, we'll just accept that for the time being. Click change and deploy. There we go. So we've got a host port there. Let's make this port that we're going to use. Sorry, let me jump back to DCOS. See if this thing is actually refreshed. So bring up the details. So you can see here that now that I've moved this thing over to the public VM and I've told it to expose port 80, it's now saying, hey, the host port here is the port that we need to set up the network to route through to. So this is where some of the complexity is. There's actually a REST API for DCOS to allow you to automate this. So now I would go into Azure, And normally what you'd do is you'd go into the agent load balancer and you would take one of these inbound load balancing rules that you've already got. So if you wanted to expose this as port 80, you would remap port 80 and route it through to that internal port that I just had up on the screen. If you don't want to do that, you can go and create another load balancing rule, and you've got to go through the process of creating health probes, and then you've got to go and set up some network rules. So we've got a network security group which you need to update. So there's a public network security group here, and you need to create inbound security rules so that the traffic can actually flow from the outside in. So there's a couple of security settings here. Going through and changing all those takes a while. So what we're going to do is just jump in and we're going to access the application directly that we've already got deployed. So if I go and look at this particular application, I've already got an application deployed on port 20724. And to figure out what address I need to type in, I go to the public address. So I'm just going to grab that port number. Make sure that's in my clipboard. And I'm going to go to the public IP address. And this is the DNS name for this IP address. So when I hit this address, it's going to go through the load balancer. It's going to be secured by the network security groups. It's going to hit the public VMs behind the load balancer in the container cluster. And my application will be served up. But I need to make sure I hit it on the right port. Obviously, you can map this to port 80 if you want. It's just the way I've set it up in this particular instance. And there is my Docker application running inside ACS on a Linux container, and it's an ASP.NET Core application. Okay, so that's the end-to-end scenario. Yay! So we've got about 10 minutes left. I covered a lot of territory there, so I guess what I would like to do is leave it up to you to let me know where you want to drill in. Do you want to know more about those security rules and have a closer look at that? Or do you have some other specific questions that you want to drill into about this? Well, actually, one thing I should do is jump in and look at the build and release definition, because that will be interesting. Okay, so if I go in and look at the builds, and click edit. So the build definition that it produces out of the box is there's quite a few steps to it, but it's a fairly well-defined one. So it pulls down the source code, and then it basically builds the Docker container, okay? Runs some unit tests, and then uploads the images. So there's just multiple steps involved in doing that. But basically, you take the Docker file, you build the container, run the tests, upload that image to Azure container registry, then the build finishes. And there's a few files that go across into the release pipeline, like particular Docker Compose files. And so if we jump across to the Docker Compose, to the release pipeline, and look at that in more detail, the release step is actually quite simple. Having done the work to produce the container, all you've got to do is instruct ACS to deploy an instance of that. All right, so we've got a Docker Compose file which came from the build pipeline. And we pass in the details of the container, which is in the Docker Compose file, plus a few other environmental information which controls where it sits within that DCOS UI, so the application group name and so on. And that's exactly the same for each environment. You're just pushing it to a different application name. So dev, test, and production are almost identical. Okay?
If you're not going to use Docker, right now, the MS build is supported. Can we use the regular Visual Studio build task, or do we still need to use the command line for .NET,
Yep, good.
.NET REST or .NET builds,
Yep.
.NET publish? Do we need to go through this, or can we just use MS build?
So good question. The question was, do we have tasks built into VSTS today which properly support ASP.NET Core and .NET Core generally. So if we go back to what I said about the project.json file, we've had a bit of a rocky road at arriving at using MS build files. And so some of the build tools are orientated towards having a project.json file, and some of them are orientated towards using MS build. And right now, as in like sort of this month, for example, we're at this point in time where we support neither perfectly, okay? But you can actually achieve what you want. So if you don't want to use Docker and you just want to deploy a .NET Core application to Azure App Service, for example, what you can do is you can build the ASP.NET Core application using the Visual Studio build. But if you just do that, it's going to fail. So if you take the standard .NET build, sorry, the standard Visual Studio build template for VSTS, there's two steps. There's a NuGet restore and there's a Visual Studio build. The NuGet restore will pass, but won't restore anything. And because of that, the Visual Studio build will fail. So right now, it's a point in time issue. What you need to do is disable that NuGet restore task and drop in the .NET Core restore. And that will restore the packages that you need to be. And the .NET restore still honors the packages.config file and that kind of stuff. I have heard some rumors about a few challenges with the VSTS credential provider, but I haven't been able to verify that myself. But I suspect that's just, once again, it's a point in time issue.
From MS build tools.
Is there a timeline to fix that one, like before the release maybe?
I don't have a timeline, but I don't think it's going to be very long because it's...
Going to release soon.
yeah. I don't want to say a timer because I don't know, but it's one of those things which has to be fixed very quickly. So I'd imagine there's going to be some pressure to get that sorted out. It's actually a relatively minor thing. What will probably happen, I suspect, is that we'll probably update the NuGet installer task so that it can detect that it's dealing with a .NET Core application, and then it'll use the .NET restore instead of a NuGet restore. And that would actually work around the problem.
When you did use that screen and you deployed out to dev test production with these containers running,
Yep.
I kind of lost the link of what kind of CPU power and RAM were you using and how much you pay for that in Azure. Like I didn't see a VM, because obviously software
Yep.
confused on that concept.
Well, it is a VM. The containers are running on top of virtual machines. There's actually multiple containers running. So one of the things that continuous deployment tool does is actually spins up a container for that entire release pipeline. So there's actually a container running the VSTS build agent inside the container service to build the container. So that's one container, and that's sitting on a VM. It's a real inception thing. So the question was where, where's the CPU resources coming from essentially, and what are you effectively paying for in terms of those resources? So what you're paying for is the VMs, basically. So when you provision, and the pricing is up on the Azure site, but the resources are really what costs the money. So
Where was that defined? Because you just sort of pushed those out and they were running.
yeah, so that was defined when you create the container service. So I didn't go all the way into that UX. I'll show you that. So when you create the container service, one of the settings is, and I can't get there without, is the number of agents you want. And so those agents become the number of virtual machines inside the VM set. Okay? And so if I jump, so it's in these screens where you define the number of agents, but if you go back into the resources I've already got, you'll see that there's actually a virtual machine scale set. So there's a private virtual machine scale set, a public virtual machine scale set, and that's what's running the infrastructure for this. And that's where the cost is, and the compute resources. And the agents are actually running on those machines. Any other questions?
Sorry if I was asleep, but I'm wondering, what was the relevance of that C program that you compiled? Sorry if I was asleep, man, but what was the relevance of that C program that you compiled? How does that relate to the rest of your talk?
So the purpose of that was just to show you, the purpose of showing you just using the Docker file with compiling a C program was just to show you Docker in isolation, okay? So this presentation relies on a whole bunch of moving parts, and so what I wanted to do was just show you each of those moving parts in isolation before we bring them together. Otherwise, it's kind of hard to sort of pick out the different moving elements. So when you guys go away and do this yourselves, there's going to be a few things you need to master, right? You need to master ASP.NET Core, you're going to need to master Docker, and you're going to have to master ACS and various Azure networking components. This process makes it easier, but you kind of own the administration of this thing, so I wanted to show you those various components.
Just on the release pipeline, you had dev, test, and production.
Yep.
Are they're separate containers that are running on one agent, or are they running on different agents?
So DCOS manages the distribution. So the question was, I've got those separate environments. Do they run on separate agents? The idea behind containers is that the container themselves is your environment. The container service is kind of a fabric, a compute fabric that you deploy those resources on. So you can have multiple environments on each of the environments, each of the container services. We could have just as easily gone and set up a separate container service and deployed just the dev bits into that container service, but there probably wouldn't be a lot of point because those containers are isolated from each other. The fact that it sets up dev, test, and prod, that's just what that wizard does. But you can go and edit it and tweak it and create more environments or less environments. It's up to you.
Where's that defined? Is that in the YAML file?
Yeah, so if we look at the Visual Studio, the question was, where is that defined? So if I look at Visual Studio, you'll see that there are a bunch of YAML files. Not only is the Docker file, which defines the application container itself, we've got these Docker compose files. And these files control how the various components work together. So if I add another ASP.NET Core application here, it will add that into these compose files so you can deploy multiple different containers which are part of the one application. And that's all defined in the container file. And if you drill down, there are kind of overrides that you can put in. Now, in this case, these YAML files aren't actually used in the deployment. It just takes that base one and passes in an environment variable or a parameter to control whether it's the dev, test, or prod. They're actually identical environments because it's just the one image. It's just controlling, hey, we're deploying to the dev app or the test app or the prod app. And that's kind of one of the beauties of containers. Okay, so I might just switch back to the other screen just to wrap things up. Okay.
Right now, the hosted agent supports only Xpros, am I right?
Sorry, the hosted agent. Actually, the .NET hosted agents have been updated to .NET Core 1.1.
But the preview is still on 2.
Yeah. So there's some missing bits. We don't have the updated version of Visual Studio and the latest bits that come down. What I've been doing with my .NET Core work is just running a private agent for the time being. Once again, point in time issue, we update the hosted images on a regular cadence. So yeah, I wouldn't be surprised. It may not be the next update, it might be the next update after that. So maybe 6 weeks tops before it's got the latest bits on it. But remember, in this scenario, the build agent actually runs inside the container service, so you don't need to worry about it. Okay. We've got like 30 seconds left on the clock. Happy to take one more question. Otherwise, thank you very much for coming along to the session. If you want to play with this stuff, you can go and get your Azure subscription credits, and that will give you enough credits to spin up a Docker container and play with this. It's pretty easy to get up and running. So I think if you want to talk about that stuff down in the expo, we've got the DevTools team, the local DevTools team, who can help you set that up. And don't forget to do your reviews, your session reviews. And I think you go into the draw to win a drone. Is that right? You guys, you've seen more sessions than me, so that sounds Sounds pretty fun to me, so please go and do that. I value the feedback, good or bad. So thank you very much for coming along to the session.